Hi, I am Sriranjani Ramkumar from Product Marketing team here at MathWorks. In this video, I'll demonstrate how to configure the pulse width modulation block for the RA microcontroller in Simulink and use it to control the LED brightness by varying the duty cycle of the PWM signal. First, let's set up the hardware. I have the RA62 controller. Let's zoom in and focus on the SAI connector. Here is the pinout of the SAI connector, and I have the FTDI chip and its pinout. Cross-connect the controller board's TX to the FTDI's RX and vice versa. Connect the ground pins together. Now, to power the LED with the generated PWM signal, connect the PWM output pin PP04 to LED pin PD02 using a jumper cable. Use USB cables to power both the controller board and the FTDI. With the hardware set up, I have the Simulink model opened for this example, where I have the constant block controlled by a knob and is connected to the duty cycle port of the PWM block. Double-click on the PWM block to see its block parameter. Provide the stack name and ensure to mention the same name as in the RA Smart configurator. Since I am controlling a single LED, let me select one of the available two pins, here GTIOCA. I am leaving the period to default configuration in the RA Smart configurator and specify the duty cycle in percentage. Click on Apply and OK. Since the duty cycle is provided in percentage, I have configured the knob to range from 0 to 100. Now let's open the configuration parameters by pressing Ctrl E and go to the Hardware Implementation tab. Select the hardware board. Now expand the target hardware resources. So here is the placeholder to include the XML file generated from the RA Smart configurator, which is used to configure peripherals. You can either create a new RASC project by clicking on Create, or locate an existing project if you already have one and launch it to view the settings. For this example, let's create a new project and launch it. Go to the Stacks tab to add the PWM stack, and it's highlighted in red because clock is not enabled. To resolve this error, go to the Clocks tab and enable the clock by selecting the GPT clock source. Going back to the Stacks tab and selecting the stack allows you to see the properties related to PWM for its configuration. For this demo, under the Common Properties, enable the pin output support. Expand the general settings of the PWM to select the channel mode and the period. Let me select channel 4 and leave mode and period values to default. Under output, set true to the parameter GTIOCA output enabled, and expanding on the pins, select the pins by clicking on the link icon. This takes to the pins tab for the GPT peripheral, and you can select the output pin. Let me select the operation mode to GTIOCA or GTIOCB and select pin PB04. Also, configure the LED pin PD02 to input mode. As we have connected the PB04 to PD02 through jumper, the generated PWM drives the LED. Save the RASC settings by doing a quick Ctrl+S. This updates all the settings in the generated XML file. And let's now switch to the Simulink environment for the further settings. Moving on, the UART stack is added by default in the RA Smart configurator when the project is created in Simulink. Ensure to enter the same stack name and channel number under the Connectivity tab of the hardware implementation. The COM port used for communication between the FTDI and the host computer can be found under the Windows Device Manager. Enter the same COM port number here as well. Finally, to enable parameter tuning of the Simulink model, go to the Optimization tab under Code Generation and ensure the default parameter behavior is set to tunable. Otherwise, the user will only be able to monitor the signal and not be able to tune the parameter. Click on Apply and OK. With all the configurations done, let's now run the model in the Monitor and Tune mode. As the model runs, let's quickly change the duty cycle knob. As you rotate the knob, you can see the brightness of the LED changes instantaneously. Hope you have learned the basic settings required to generate the PWM signal. And thanks for watching this video.